Hello, hello. Hey, Kennedy. Woo. Kennedy's in the house. Hey, if you could name this song you hear, let me know. Say hi to Harold. All right, that's enough nonsense. Hope you guys are doing well today on Tuesday. And let's get started. And hopefully we'll have a few more people join us. But today we are going to be talking about our scientific method experiments. And so I'm going to ask a question. And while you're answering, I'm going to talk about the next thing. I will tell you, I did not do too much yesterday as far as going through things that have been turned in or things that people are working on. Like the Google Docs, they're interactive. I can look at them at any time, even if you haven't turned them in. And I was feeling pretty bad yesterday. Feeling much, much better today, in much better mood. I'm happy. I'm not sick. And I'll be looking at that stuff today. So my question is, have you started, do you have an idea for an experiment? Question number one, do you have an idea for an experiment? If so, send it to me. Number two, have you started to make your materials list for your experiment? And so that would be no, no, yes, 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 no, 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 yes, 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 no, no. Third question is, did you already start your experiment? It stopped, whatever that means. And so, anyways, those are the questions. I don't know what it stopped means. Maybe you can elaborate on that. But let's talk about a materials list. I got a couple examples of what a materials list looks like. I'm going to post them right after our class here. I will post them, and it'll give us give you a chance to look at a couple examples of what a materials list might look like. And so no, 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 no. Everything's a song, Kennedy. All right, so I guess that means you haven't started. That's fine, because we want to do things right. Okay, really, before you start your experiment, if you and please, if you like absolutely do not have any idea, I don't know what to do, Mr. Soriani, I'm clueless, I'm lost, blah, blah, blah. I don't know what I can do at home. Message me, either email or in Google Classroom. I got my, if you look at the chat, I got my email address there. You can also message me in Google Classroom. And that way you can, if you're struggling with that idea, then you can, I'll work with you and we'll come up with an idea. A lot of that will be based on what you have at home. All right, so let's talk about what a materials list looks like. I'm going to be posting one as soon as the class is over of what I actually have two examples of materials list. But I'm gonna give you a materials list right now and see if it goes anywhere in your head. What you think the experiment is about. And so I'm going to read off the list. Okay, 16 pieces of glass. 16 pieces of glass. 5 different brands of SPF 15 sunscreen. 5 different brands of SPF 30 sunscreen. 5 different brands of SPF 50 sunscreen. A ultraviolet or UV light meter that measures the amount of light of UV light. A bottle of glass cleaner. A box of disposable gloves, a piece of cloth, a pair of thick safety glasses, and a wooden box. You know what's missing from this materials list is something to record your data on. Could be a notebook, right? Okay. So that is kind of missing from this experiment. What do you think that's about? You've got 15 different sunscreens, a ultraviolet or UV light meter that measures UV light, and 16 pieces of glass. Think about that for a minute while you guys are thinking about that. I'll give you a different example of a materials list. A compact disc player and a compact disc. 3 separate flashlights. A camera with a flash on it. AA size, either Duracell or energy batteries. What's the problem with that? It doesn't give a quantity. AA size of a heavy duty battery. A voltmeter, and a voltmeter checks how many volts are left in a battery. So if you have a 9-volt battery, the little pocket battery that goes in a lot of small devices, if you put a voltmeter on there, guess how many volts it's going to read, especially if it's brand new. It's a 9-volt battery. 9-volt battery. How many volts should it read? All right, if it's new. What about if it's old? And a kitchen timer. Ooh, I've got a kitchen timer right here. Kitchen timer. Should I do it like this? I've got a kitchen timer right here. All right, so I have no idea what this experiment's about. That's a materials list, and I don't know what the experiment is about. The other experiment that I told you about, I don't particularly know what that experiment is about, but based on what's there, I can guess. My guess is they're measuring whether different brands of sunscreen actually block the amount of UV light or ultraviolet light that they say they do. Okay? And so the point of wearing sunscreen is to make sure that you don't get too much exposure to ultraviolet light. Why? You get sunburn, right? For one, long-term exposure could cause skin cancer. And so there's a lot of good reasons that it's good to have a brand of sunscreen that's effective. So I can tell you that this list tells me that it's an experiment about sunscreen and the effectiveness of sunscreen. If it says SPF 50, is it actually what it says it is? Is it blocking the amount of UV light that it's supposed to? That's a pretty cool experiment. You don't need that many lotions on you, no. You could probably do this experiment with a few if you had a UV meter. I don't know too many people that have got a ultraviolet meter sitting around the house. Maybe we need to order one, Mr. Fosnight. If they're not too expensive, that would be pretty cool. All right, so that's one example. This other example, I can't even tell. Let me click back to it. What the experiment is about, but I imagine it's about, if I had to guess, it's about how much energy different devices drain out of a battery. You got a CD player, you got flashlights, you got a camera flash, and you got batteries. Okay, so they may be testing, how much energy is drained out of a battery through a certain device. All right, so is that an experiment you can do at home? Absolutely. With batteries and things that need batteries, it could be a flashlight. I'll tell you one example of something that I could do in my house. I have an older flashlight that has a regular incandescent bulb. And I also have a newer flashlight that has an LED bulb. Okay, two different types of bulbs. Which one will last longer? I could actually do things like, if I had a thermometer, measure the amount of heat that they produce. So you can do things with batteries. You can do things with cooking. Kennedy, I don't know if you like to cook, but that would be cool to do something with food, if you had an idea, something with food. There's a lot of ideas you can come up with. The importance of having that materials list being complete, it's pretty important. It's kind of like making a peanut butter and jelly sandwich, right? And so you make your materials list and you say, oh, I need peanut butter. Oh yeah, and I need jelly and I need bread. Okay. That's a pretty good start to a list. Well, that's worth it, $40 for a meter. That's a pretty good list, right? Peanut butter, jelly, bread. How are you going to spread the peanut butter on the bread and the jelly on the bread? Maybe you've got one of those squeeze bottles for the jelly or whatever. I don't think they have one for peanut butter. You pretty much need more than, and are you going to make it on the couch or on the counter or in a plate or on a napkin? And so I would say plate, definitely me. Probably paper plate because I don't like doing dishes. Hi, David. And so does that need to be part of your list? Even the little things. All right, so if I'm making a peanut butter and jelly sandwich, I need peanut butter, I need jelly, I need bread. I also probably need a knife and or a spoon and a plate. And that would probably be enough to do it, right? And then along with eating it, you probably need a napkin because you're probably going to get peanut butter all over your face, depending on who you are. All right, so what happens if you make a materials list and you start your experiment and you've screwed up? I said this the other day, and you go, a little light bulb goes on above your head and you go, oh, I forgot something that I need to add to my experiment, to my materials list. Fine, go in and add it to it. Just do it in a different color. So if you made your materials list and it's just in black font and you have an addition to add to it, just do it in a different color, red or blue or something. You don't need sleep. You want to do an experiment on sleep, Kennedy? That's fine, but we'd have to be specific about what we're going to measure. And so if you make a mistake in your materials list, don't worry about it, because chances are you're going to. This one that's posted online is not really precise enough. And because it doesn't say quantity of batteries. Do you need 2? Do you need 22? How many do you really need? How many different devices are you checking? So it's important to be super specific. And if you aren't, and you realize that you weren't afterwards, go back and fix it. Just do it in a different color. So you go, yeah, I figured it out. I need this. I forgot about that, but it makes total sense. So when you start doing your experiment, then you need to, and I'll post these, you need to do things like, for example, this experiment with the batteries. It says, name each battery so you can tell them apart, or number each battery. So if you're doing something and you have 6 batteries, you're going to number them 1, 2, 3, 4, 5, 6. Yeah. And Mr. Fosnite is absolutely right. When you go in and make corrections on things, that means that tells me that you're learning, that there's a learning process going on. This project is worth 100 points. In each section is worth 15, and the experiment is worth 25. And so you do have to do each step. Today we're talking about making that materials list and doing the experiment. So let's say you're doing something with food. Let's say you're going to bake bread. Okay, so what do you need? If you're starting from scratch, you need flour, you need yeast, you need water, you need a pan to cook it in, you need an oven, yeah. You need a whisk or a mixer, either a hand mixer. I don't know if you guys know what that even means. That either means roll down your window because I want $1. That's if you're on the corner of, well, down there by the shop down there. No, all right. So, anyways, you guys, some of you might know who I'm talking about. That either means roll down your window, I want $1, or you're mixing something by hand. That's the old-fashioned way, or you got an electric mixer. All right, so make sure your list is complete. And if you made one already and you forgot something, you're like, oh yeah, just add it to it. Do it in a different color. Procedures. Make sure you're following your own procedures. And same thing with writing your procedures. Number each battery. Use the voltage meter to measure, and this is about the batteries. Use that voltage meter to measure how many volts are in the battery beforehand. How many are in the battery? How many volts are in the battery after you're done with the experiment? And so one of the things on your materials list needs to be notebook paper or graph paper or an online graph somewhere where you can record your data, okay? Because I will say this, one of the biggest things that people do wrong is not accurately recording data. They've done an awesome job of making a materials list, writing their procedures, and they start to do their experiment, and they're excited about it, and it's going real well. And what do they forget to do? They forget to record their data. And there is a reason why, and I said this to the other class, there's a reason why I didn't give you a template to use, because depending on what you're doing, you could be recording different data. If you're doing something, let's say you're baking something, okay, did you use a different amount of flour each time? Did you use a different temperature? So let's say we're recording temperature. What about the time? And so we could be recording temperature. We can make a variance in the time that we're using. how long we're prepping something, how long we're baking something, what temperature we're baking something at. So you're talking about different data points. So very easily you can have 2, 3, 4, 5, 6, 7, 8, even up to 10 different data points that you're recording on your data sheet. So you very simply can just take a piece of paper and make some lines. It doesn't have to be neat. Make some lines and record what data, what information do I need? Do I need to know the temperature? Do I need to know the length of time? Do I need to know when I'm observing, what am I observing? Am I observing smell? Am I observing color or what it looks like? Is there something I can hear? Is there something I can smell? In the case of something that you are allowed to taste, like food, what do I taste? What is the texture? If I touch it, is it gooey? Is it cooked thoroughly? Blah blah. So there's a lot of questions that you can ask. Can I, if I'm making a loaf of bread, can I measure how much it rose? Was it flat? Did it raise up really high? Was it just right? There's a lot of different data points that you can measure. And so you need to create your own table. Again, you might say, get into the experiment and say, I should be recording this too. And I didn't put it on my list. Just add it to the bottom. Put a star next to it. Draw a little star next to it so that we know that, hey, this is something that I didn't think about until I was doing the experiment. That's a learning process. That tells me that you're learning something as you're doing this, and that's what I want to see. Measuring precisely is another important thing. One of the things we get, and I can show you with these rulers, okay? Here is 1 inch, okay? I'm trying to get where you have a good background, maybe my forehead. But 1 inch isn't from here, is it? Where's the 0? The 0 is actually there. So are you accurately measuring something? Are you using a measurement properly? If you're looking at a beaker, are you looking at it here, or are you getting down and looking at it from a level standpoint? You can get a very different measurement if you're trying to measure, well, that looks like 200, but when you come down here, it's only 175 milliliters. You will get a different topic or a different measurement based on your perspective. So it's important to measure really accurately when you're doing this. I expect you guys to take pictures of your experiment. And if you can't load them up into Google Docs or send it to me as a message, that's fine. You have my email. I want to see a picture of your experiment. Normally, we would get to do this stuff together. And I'm telling you, we have fun doing this. You guys know when we get to do experiments, they're fun. And part of me being able to give you a grade will be, okay, let me see what you actually did. In a way, I guess that might be keeping you honest. And the last thing I'm going to talk about is just having what I call intellectual integrity. I'm not at your houses, and we're not at school. And yeah, you can cheat your way through everything, but I don't want you to do that. I want you to be honest about what you're doing and have an interest in what you're doing. Pick something you're really interested in doing. And so if you're struggling to come up with an idea, send me a message that says, I don't have an idea, but these are some of the things that I like to do. And maybe that'll help me help you come up with an experiment. We're at the point where we do need to get started on these. And so that's where we're heading. Once we do get started on these, we'll have some other work we'll be doing kind of simultaneously to go, that goes along with it. We'll be doing some other concepts. I might even, I haven't decided yet, but I might actually do an experiment that you can watch to give you some ideas of something that you can do. I hope that helps you. If you don't have any questions, that's fine. And we'll be back on Thursday. Again, like I said, I did not get online very much yesterday, just in the morning. Was not feeling good yesterday, feeling much better today, thank God. And hoping that you guys are having a great day and a great week in spite of kind of being stuck in our houses. It's good to see some of your names up there, and thank you for joining us. And we will, I'll see you on Thursday. By the way, Mr. Fosnight's got a really cool experiment going on, and I know he's going to want to share that with you guys too at some point. And he can help you too. And he's somebody that you can also email if you don't feel comfortable emailing me. So that's that. We're about out of time. And for now, let's see. What is the word of the day? The word of the day is haircut. Yeah, I got a little bit of a haircut. I did not go to the barber shop. My wife did it. That might make Jacob Smith mad because he thinks dudes cut hair better than women. All right, you guys take care.